Okay, so today I'm gonna talk about the junction capacitance and Schottky diet. So in the middle of the PN junction, there is a electric field, and we can think that electric field is similar with the capacitance because also the electric field is in the capacitance. So that's why we call the junction capacitance, and we can actually figure out how how amount of the capacitance because we know the formula. The C capacitance is epsilon area over width, depletion width. So by that formula we can know that uh, in the NP junction diode, and if that diode is more doped in N type, then capacitance is area times square root Q epsilon N A, which is current concentration, over 2 times junction potential, like this. So in this formula, we could know that uh, capacitance, junction capacitance, is proportional to the 1 over square root junction potential. It is actually not proportional, is improportional between junction potential and junction capacitance. Okay, so the next thing I'm gonna talk about is Schottky junction. So when we see the semiconductor, there is a junction between metal and N type. So we have to know the what's gonna happen in that metal between the N type. So when we put together, there is a potential barrier, and that formula is metal work function minus electronic affinity, and that is actually practical knowledge. And in real, when we see the real semiconductor, actually the most of the potential barrier is positioning in the half of the potential difference. If the n type is if n type is Si, then it will be 0.7 volt. That is the Fermi level pinning. And lastly, how do we figure out the Schottky barrier diode? Uh, um, the solution of that is mm, doping heavily between metal and semiconductor. That causes the tunneling effect, and that tunneling effect makes easily to charge go over to the semiconductor.